to you in science video. This video is all about black bodies. What is the best colour then that absorbs electromagnetic radiation, that emits it and that reflects it? Hopefully we'll address some of these questions during this video. Well, what is a black body? Well, a perfect black body is an object that absorbs all of the electromagnetic radiation that hits it. This is only theoretical though. You won't really meet a black body. Absorbers versus emitters. So you can absorb electromagnetic radiation or you can give it out, which is what we call emit. Now a good absorber is also a good emitter. Emitters then, well, all objects emit electromagnetic radiation. The amount of electromagnetic radiation that is given out depends upon the temperature. The electromagnetic radiation that is given out is mainly infrared radiation. But they also emit other types of electromagnetic radiation of varying wavelengths and frequencies. We therefore come across this word intensity. Intensity means the power per unit. As temperature increases, the intensity of every wavelength also increases. This means more energy will be transferred in a certain period of time, the hotter an object becomes. So as an object gets hotter, the peak wavelength will decrease. This can be shown via a graph, where at 3000 degrees Kelvin, we can see the peak is here, between the orange and the red, as where at 6000 degrees Celsius, when it's hotter, the peak is more at the green part of the spectrum. The wavelength decreases the hotter the object becomes. On Earth then, this is important, because we receive radiation from the sun in various wavelengths. Some of this radiation is reflected back into space by our atmosphere, our clouds and bright surfaces, while some of it is absorbed by our atmosphere and the Earth's surface. Now the Earth's temperature is determined by the rate at which absorption, reflection and emission occurs. During the daytime, more is absorbed than emitted, and therefore it feels hotter. Where at night time it's the opposite. More is emitted than is absorbed, and therefore it feels colder.